Today, you're going to get a chance to see 4 seniors do the lab that you've been doing in class. Welcome to Chemistry All-Stars.
So the prompt is to determine the identity of 2 unknown chemicals using the melting point table. Also, we have to design an experiment to answer the prompt. And remember, you are expected to refine and prove your experiment multiple times, analyze the data collected, and during the experiment, you design.
So it's kind of awkward because we have no idea what we're doing. We kind of went in with only one toe in the water, so you know, it's kind of complicated.
What type of chemicals are there?
There's lauric acid, paraffin wax, stearic acid, bethylamine, benzo, and acetophenone.
We should probably figure out a way to get these chemicals at different temperatures. So that way we can determine like what this one is, because we don't know. So I think like one of the easiest
So
ways.
should we kind of elaborate on the melting points for each of the
Yeah,
compounds?
yeah. So let's look at the different ones.
Our group is doing okay. We're still on the fence as to how to go about things, and that's why we've been going back and forth as to how things should work out. We haven't set positions. Since we're a team, we decided that we all share equal part. So some may participate more vocally, but we still find a way to communicate equally, whether it be taking down the data, recording the data, being a timer, so things like that.
All what we have, right? We have a beaker, we have a faucet, water. We have some scales over here. A scale.
We got a heat plate.
We have a hot plate.
And
So we have the melting points here.
that's for each of the different.
We also have a
compounds.
thermometer.
So we could heat up the water, put water into the
Into
beaker.
the beaker.
How
Keep
much
the-
water?
Probably enough to submerge the chemical. So if we put,
How much of the chemical do you want to put in?
So we're including like specific measurements for the chemical and the water, and specific directions for what to do with all of the parts of the experiment. Wade started out in the beginning, so he was kind of like a leader then. But we're all kind of putting in our own ideas.
we should put the chemical, in my thesis, my theory. If we put the chemical in the test tube and then submerge that in the water, we can measure the temperature of the chemical by just putting the thermometer into the tube.
Okay.
Yeah, I agree.
All right.
Should we write out a procedure first?
Yeah.
Yeah, probably.
So we have to figure out how much we're going to use of the chemical and how much water we're going to put into the beaker.
Okay.
So, what do you want to use for it to submerge completely?
You can do like 100
100?
milliliters.
100 milliliters of water.
Yeah.
Oh, is the beaker clean?
Well, if the chemical is in here, it doesn't really
Oh,
matter
yeah,
that
yeah,
much.
yeah, that's true.
So 100 milliliters of water.
Oh, I know what we need.
Oh, we need to grab the units in there.
Yeah, we got that now. Alright, so doing experiments like this, when I first learned how to do it, I wasn't really impressed because it seems simple, it seems straightforward, but I thought about things that happen in the real world, like things that investigators go through, forensic specialists, and there's actually a lot of like real purposes behind this. Like you might have to one day examine a chemical that no one has ever like studied before, experimented before. So knowing how to really set up a proper like experiment like this one where you're measuring temperature at like different time intervals constantly for, it could be like anywhere between 30 seconds and a minute or 2 or 3 days. You never know. So this like type of science, like this is chemistry. So chemistry can be used everywhere, and I think one very cool thing about this project in general is just being able to think about it in real world context. So like I said earlier, like with forensic specialists or medical examiners or even nurses and doctors, I'm pretty sure have to do experiments like this.
Wait, how much are we putting?
100 milliliters of water and then 10. Put another scoop in there.
There's no more scoop?
Yeah.
Because that wasn't a full scoop, so I think like one full scoop is about 1 gram.
How's that?
That's 1.3 grams. $2.1. Maybe we should just go with like 3, because that is a lot, you're right.
Yeah.
That's 2.8.
Next time on Chemistry All Stars.
Alright, so what's the temperature now?